Okay, you guys, so if you can write trapezoidal rule on the top. And actually, I normally don't call it two separate things, but we'll also write it as trapezoidal rule and sum, because there is a distinction between the two, and we'll talk about what the distinction is. Okay, so under this, let's first sketch a picture. Okay, so we're going to draw a function, a representative function, and the trapezoidal rule does the same exact thing as the Riemann sum. It approximates the area underneath the curve. It does approximate an integral. So let's say we had a curve, and we call that curve f of x. And then underneath that, let's define a starting point for x being a, and then an ending point called b. So our interval is from a to b. And then within that, go ahead and parse it out into however many partitions you would like. It doesn't matter how many. So it's just representative of this function. So in this case, like if you guys had 6 and I had 5, that's fine. It's just a drawing just to represent what we're doing here. So we had learned prior to this, Riemann sums with rectangular approximations had that it was, and don't do this part of it, but you might have seen that it was an under approximation if we did the left Riemann sum, or it might have been an over approximation if we did a right Riemann sum, with the midpoint being pretty good because part of the rectangle went over and then part of it went under. However, this other shape that we learned in geometry called a trapezoid actually does a better job of fitting to the area underneath the curve. So here you guys see a trapezoid that's representative of what we're trying to do next. So what I'm going to have you guys do is take that the trapezoid and draw it over on this side, and let's change the orientation so it's horizontal instead of vertical. And the reason why I'm doing that is just so that you guys can see we're more familiar with trapezoids when they're faced this way as opposed to the other way. So I have a lot of confusion sometimes with, well, what's the base, what's the height? In the private chat, can you guys type out for me what you guys remember about the area of a trapezoid from geometry? What's the area of a trapezoid? And also, you guys, the area of a trapezoid is one that you do have to memorize. Go ahead and type out the area of a trapezoid. And I like to see this because there's more than one way to write this formula, and I see like all the various ways coming through on how to find the area of a trapezoid. So definitely for sure have this formula memorized, but a lot of you guys have a half height times base 1 plus base 2. Okay, the bases are parallel to each other, you guys. So in this picture, what I'm going to do is, let me erase the highlighting parts in here. And what I'm going to do is highlight the bases. So these are the bases. These are the parts that are parallel to each other. This is B1 and this is B2. The height is the difference or the altitude between B1 and B2. So in this particular picture, this happens to be my height. Okay, so all of that you guys knew, especially in particular with the trapezoid orientated horizontally. So here's my question back to you guys. So now what we're going to do is because we partitioned the interval into subintervals, we're going to define each one of the x values in a more general term. So let's say that we started off the first x value. Let's say a is called c sub 1. The subscript is just to say that's the first x value. The next one would be c sub 2, c sub 3, c sub 4, c sub 5, all the way, assuming, and that's the idea that calculus brings to it, right? It's not just that we only have 5 or that we had 6 or that we had 7, but that there's an infinite number of trapezoids that if we were able to fit that underneath the curve and use that as an approximation, it would give me a really good, almost exact value of what the area is underneath the curve. And we like to have this option because unlike a derivative, when we integrate, there's going to be times when you don't know what the integral or the antiderivative function is. And so at best, all we can do is an approximation of what that area is. So here, when I get to B, to represent that there's an infinite number, let's call it C sub n, where if we were to let n go to infinity, what happens is we reduce the width or the height between the trapezoid so that it gets closer and closer to 0. Same idea as a rectangle. So in the chat, can you guys let me know what values would you guys use to represent the base? So according to the picture that's drawn, what would represent the base in your picture? Like what notation would you guys use for the base? Okay, good. And I guess be specific in terms of, is it X values, is it Y values? And how would you represent those particular values? So I see some of you guys writing, just like when you guys had length and width, here, this value here, this value here would represent the value of the bases or the length of the bases. And if I were to generalize what that is someone just typed into the chat, f of c sub 1, that's the y value. This is the y value, f of c sub 2. And just keep going on so that you guys kind of get a sense of where you're getting these values. C sub 4, f of c sub 5, all the way to the end where you guys have this y value is f of c sub n. Okay, so if I wanted you guys to be able to picture that. So the base values of your trapezoid are your y values. Your height of your function, remember your height of your function is what the subinterval is. So if I had to represent the subinterval, remember there was a formula for it. The change of x is eventually going to be my height. And the formula for that was b minus a over n. And that's the same way we did change of x when we were doing Riemann sums, or the width of each one of the rectangles. So change of x, b minus a over n, is going to be the value of the height. Okay, so we're going to take all of this and we're going to put it together in a formula. So I'd like for you guys to see where this formula comes from, because in recent years, the AP test has moved away from what they call trapezoidal rule, which is, you know, when you hear the word rule, it sounds like, okay, just follow this formula. And really that's what it is. The trapezoidal rule is a formula for you guys to find the area underneath the entire curve, assuming that your subinterval is constant. So assuming that you have equal subintervals. So this is assuming that each one of the heights here are equal. I know it's not drawn to scale here, but assuming that they're equal. So let's say we crank out this formula to come up with what it is. So we said that the area of any trapezoid is equal to 1/2 height times base 1 plus base 2 quantity. Okay, and so if we wanted the total area, what we would do would be the area of the first trapezoid plus the area of the second trapezoid plus ... the nth trapezoid. Okay, so let's start with the first one. And we just do a few and kind of get an idea of where the formula comes from. So the first trapezoid, we have 1/2. In fact, maybe I do this at the beginning. You guys, in the area of each one of the trapezoids that you guys see here, this one, this one, this one, do they all have a 1/2 in it? Yes or no? Do they all have a 1/2 in it? Okay, so since they all have a 1/2 in it, just like when we were doing this with the rectangle, I'm going to leave the 1/2 on the outside, so I don't have to write it a bunch of different times. Also, if it is a fixed width that represents the height, that represents this value, then I'm going to go ahead and also write b minus a over n on the outside of my parentheses. So 1/2 b minus a over n, and again, this is change of x or the height of your trapezoid, so they all have that as well. And then for now, within brackets or parentheses where we would then put the base values, remember you guys said that the base values were the y values. So take a look at your first trapezoid. The first base value is f of c sub 1. Does everyone see, yes or no, that f of c sub 2 happens to be the base of this trapezoid as well as the base of this trapezoid? Yes or no, you guys see that? Because then that's part of the formula. Does everyone see how this base is shared between both trapezoids? However, the first one only is written once. So what you see is like, okay, well, the area of the first trapezoid would be the 1/2 height is on the outside. F of c sub 1 plus f of c sub 2 would be the base values for the first trapezoid. The second trapezoid would have the base value of f of c sub 2, again, that repeated base, plus f of c sub 3. You guys can see f of c sub 3 is also shared. F of c sub 4 is also shared. So I'm going to go out to c sub 3, and then go ahead and put dot, dot, dot. Okay, all the way up to the second to the last term. The second to the last term, if we had to come up with a representative, I know it says c sub 5 here, but one less than c sub n would be c sub n minus 1. So c sub n minus 1 is also shared between this one and this one. So what we'll do is write f of c sub n minus 1 plus f of c sub n minus 1. And then when you guys get to the very last base, you see that really the edge, this one and this one is not repeated. The first and the last is not repeated. So the formula, if you guys flipped open your calc book or your study guide for the trapezoidal rule, would have this here, except for we combine these two terms. That's 2 times f of c sub 2 plus 2 times f of c sub 3. So basically everything but the first and the last is doubled, dot, 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 plus 2 times f of c sub n minus 1, plus the last one is not repeated, so f of c sub n. Okay, the caveats for using the trapezoidal rule is trap rule is only used if subinterval is fixed. So in parentheses, the subinterval happens to represent the height. So if you guys had equal heights, so I'll put the parentheses here actually. If you guys had equal heights, I don't know why my S came afterwards. Okay, so if each one of the trapezoids have equal heights, again, if I had drawn this to scale, that would mean that this would be the same as this, would be the same as this. So we can use this rule so long as that is true. Okay, so then the question is, well, what if you wanted a skinnier trapezoid here, but a wider one here? How would that change? And so the simple answer is that they're going to give you guys problems where not in recent years, they kind of threw a curveball one year. I don't know what particular year, but in recent years, instead of being able to apply the trapezoidal rule, which has this specific requirement to it, what they've done is then they've taken a table of values, and they might give you guys changes of x, like the difference between one x value and the next is different as you move from left to right. So now we see that we have trapezoids with different heights tied to it. And so we can't just blindly apply this rule. And so what we do instead is use something called the trap sum. Okay, so trapezoidal sum is basically you guys crank it out the long way. Find area of each trapezoid. So each trapezoid and sum together. So nothing fancy to that. It's just that we basically can't use this as the height because they're not fixed. So it's like here, it was nice because I could factor it out of this. But with the trapezoidal sum, we just have to go each trapezoid, calculate it, and then sum it together. The nice thing is you guys don't have to really think of a brand new formula for it. It's really just geometry and then understanding that the y values are your bases, and then how to find the height is the change of x. Okay, so I'm going to do one similar to the ones that you guys have on your homework assignment, where you can use the trapezoidal rule. So example 1, you guys are gonna, if they didn't say use trap rule, you would be able to also figure it out based off of the wording, where if they say equal subintervals, you would know, okay, well, if it's equal subintervals, it's equal heights, so therefore I can use the trap rule. And I'm going to change the way the problem looks a little bit. I'm going to say use the trapezoidal rule to estimate an integral. Okay, so an integral from 0 to 3 of x squared plus 1. Okay, and again, I know for this one, I can find the exact area by just finding the antiderivative and using FTC, or fundamental theorem of calculus, and plugging in 3 and then subtracting out the antiderivative with 0 plugged in. For our purposes for this one, they want us to just use the trap rule to estimate that, that value. So what I would do if this was a free response and you guys had to do something similar to this, you would do the little squiggly equal sign to say this is an approximation. And also on the AP test, most likely they're not going to give you guys one that you can actually integrate or find the antiderivative of, but you would see an expression in here that would be something you can't find the antiderivative of, or I think more common is a table of values where they give you those the y values already. Okay, so because it's equal sub, use trap rule to estimate the integral, and then I forgot to say using 6 equal subintervals. Okay, and that's the important part. That's how I would know. Let me highlight that. I can use trap rule. So if it doesn't say 6 equal subintervals, you would know, okay, I can't do that. Okay, so in the first part, we see with the trap rule, you guys have 1/2. The next part, we have to figure out what the height is, or the change of x. So we're going to do b minus a over n. Remember, the upper and lower limits of integration are your a and b values. So we would do 1/2 and then 3 minus 0 over the number of trapezoids we want, which is 6. And then in parentheses or brackets, what you would then do is take the first value the first x value that you have, and that's not repeated. So again, in this picture, it would be f of c sub 1, where whatever c sub 1 is your a value. So in our case, we would do f of 0 would be the first one. Can you guys type into the chat, what do you think the next one is? What do you think the next expression is in this, or the next term is in this, inside the bracket? And if you guys were thinking about the change of x, and maybe some of you guys will adjust your answer after I mention this. So the next part is we have the shared same base, right? So it should be 2 of something. And then secondly, how do I know what x value to use after that? The x value you guys would use after that is, remember, you're going from 0 to 3 with 6 subintervals. This is what my change of x is. So it wouldn't be f of 1 here, right? If the change of x, good. Some of you guys are adjusting your answer. The change of x is 1/2, which means that your next x value would be 2f of 1/2. Can you guys go ahead and type in what would the next one be after that? Okay, much better. So 2f of 1. Can we keep going here? 2f of 1.5. So basically, we do this until we get to the second to the last one. It should be the last one that we double. And then the last b value, or your x value, being 3 would show a coefficient of 1, so f of 3. And so if we had a table of values, the table of values would give you guys what these y values are. And so that's what we're seeing more and more, is just that a table of values provides you guys these values so that you're not actually having to find the y values here. So what what we would do next is, well, what does f of 0 mean? So I just want to make sure you guys understand this. This is the function you're trying to find. The integrand represents the function you're trying to find the area or estimate the area underneath. So that is f of x. And so when they say f of 0, you're plugging 0 into x squared plus 1. Okay, so I'll give you guys the values just to make this a little quicker, because I know it's tedious if we were to sit there and crank out some of those values. So 1/2, and just to simplify this out, 1/2. And then f of 0 would be 1 plus 2 times 5/4 plus 2 times 2, 2 times 3.25, 2 times 5, 2 times 7.25, and the last term would be just 10. If you guys were on the AP test, you would have to go one step further. Again, you won't see one like this where they're going to make you guys find that many y values for a function, just because it's super tedious. And they write it in a way so that these y values are provided for you. You at that point, even if you guys pulled these values from a table of values, you may leave your answer like this, unless you guys need it for like that value for something else later on. You can leave your function or your expression here unsimplified. And if for this purpose, if you guys were to simplify it, or you had a calculator, it's 12.125. So we're saying that the approximate area, just using 6 trapezoids, of the integral from 0 to 2 of x squared plus 1 is 12.125. Okay, so that takes care of the trap rule. I did want to show you guys an example on your homework that you would use the trap sum for. So if you guys can find your packet at this point, I'm going to come back to this in a minute. Let me find the page so I don't give you guys a headache here scrolling. Let's start with that. Tonight you had on your homework assignment, can you guys take a moment and read on page, let me see what page number this is, page 10, the John's hair rate loss problem. And I'm going to fill in the table of values for you guys. So I realize some of you guys probably didn't print it off, so I'll just leave it on the screen on top there. If you did print it out, for some reason the image did not print out correctly. If you don't have a chance to write down all of the values, I did upload this little graphic to Canvas under the homework assignment, which I believe is homework 24. Okay, so an interesting problem here, and it's going to lead us into the next idea, is the idea that an integral represents an accumulation of a function. Okay, so in this case, they're giving you guys the day, these are your x values, and your y represents a rate of change. Okay, and the rate of change is hair loss in follicles per day. So y is hair loss and follicles per day. And using that idea that it's a rate of change and the accumulation idea is that if I were to integrate from 1 to 14, I would accumulate whatever the unit of measure is here, the number of follicles that were lost during that 14-day period. So there's a lot of problems on the AP test where they ask you guys to interpret, well, what is that integral? And if you're integrating a rate of change, what happens is that you're accumulating the unit of measure that is on the numerator portion of your rate of change. So when we were doing velocity, and velocity is miles per hour, the numerator part is the miles. So you're accumulating the total distance, or the number of miles that was traveled between, let's say, 0 and 60 seconds. Okay, so something quick. Whereas this one is over the number of days, this being your, so actually let's write out the integral. So the integral from 1 to 14 of your y value, and y just represents the function. So this is the function. If we're looking at that as and a rate of change function, again, that's the accumulation of the amount of hair loss that occurs from 1 to 14 days, or over that 14-day period. Okay, so I want you guys to take a look at the table of values. If I were to plot this, what do you guys notice about the change of x? What do you guys notice about the change of x? Something should appear as suspicious, I guess. What do you guys notice about the... Okay. So someone wrote that the change is not uniform. It's not the same. And so that it's not equal increments. And remember that this change right here, this change of x, represents the height of each one of those trapezoids. So if they want me to approximate this using trapezoids, the trapezoids are not going to be equal. So I can't simply just do what I did on the trapezoidal rule, where I take 15 minus 1 and divide it by however many days that they want, or intervals. Six trapezoids here, so divide it by 6, because it's not equal. So then therefore that tells me I can't use, so I'm going to write that here. You can't use trap rule. Okay, so if your intervals are not equal, you guys can't use trapezoids, or sorry, trapezoidal rule. You can use trapezoidal sum. So what that means is that, and I'll start you guys off on the first one, is if you want to approximate this using trapezoidal sum, you're just cranking out the area of each one of the trapezoids individually, which means, let's say you guys were to come up with the area of the first trapezoid. So the area of the first trapezoid would be 1/2. Can you guys type into the chat, what do you think the height is of the first trapezoid you're going to calculate? What is the first height? Okay, many of you guys typed in 3. We got 3 from taking 4 and subtracting 1, right? That's our change in x. So 3 here. And then what do you guys think you use for your base values? What are your base values for your first trapezoid? Okay, excellent. Everyone typing it in is correct. 2 and 7, the y values. Remember, the y values represent your height. So good, 2 plus 7. And then you keep going, you guys. So then the next one would be, what's the height of the next trapezoid? What's the height of the next trapezoid? Good, and pay attention to the fact that the height of the first trapezoid and the height of the second trapezoid are different. And that's why we can't simply just factor it out. Okay, so 2, good. And then what is the base values of your second trapezoid? What's the base value of your second trapezoid? Good, I think you guys get the hang of it. So keep going with it for your homework assignment, but I wanted to show you guys just an example. Don't put ... but just finish off the problem for that, as you're just